So again I came with one more theorem. Okay, so derive the maximum likelihood of the parameter of normal distribution with mean mu and standard deviation sigma. So that means what we have to do is, by taking the normal distribution formula, we have to prove that mu and sigma values, sigma formulas. That means what is the formula for normal distribution? F of x equals to 1 by sigma root 2 pi into e to the power of minus 1 by 2 into x minus mu by sigma whole square. Isn't it? So this is the normal distribution formula. Okay, so normal distribution is nothing but it is a continuous distribution. So here we took here f of xy because it is a probability density function. So that's why we denoted it with f of x. Okay, so now by taking this formula, we are going to prove that mu value and sigma value. So what is mu value? We have to prove is 1 by n summation xi we have to prove, and sigma value is square root of 1 by n summation xi minus mu whole square we have to prove. In place of mu we can also keep x bar. Okay, this we are going to prove by using what? Normal distribution formula. Okay, so now let's see how to prove this one. Okay, so proof. So first we'll write what the given data. So given that the normal distribution with unknown values. With unknown values is nothing but mu and standard deviation. With unknown mean mu and standard deviation sigma. Okay, so these two values can be proved with the help of what? Normal distribution formula, PDAF. That means probability density function. So we know that the PDF of the probability density function of normal distribution is nothing but f of x equals to 1 by sigma root 2 pi into e to the power of minus 1 by 2 into xi minus mu by sigma whole square. So this is the formula for what? Normal distribution. By using this one we are going to find out the value of mu and sigma. Okay, so first step is nothing but we have to write this PDF of normal distribution in maximum likelihood function. Okay, to write the function of normal distribution in likelihood, maximum likelihood you can say, or else likelihood function. Okay, yeah. So that is nothing but we have to denote with L, f of x. In place of f of x we have to write what? L. That means likelihood function mu comma sigma. That means we are going to find out these two terms equals to what? Pi. Pi indicates what? When the terms are in multiplicative format we can use this pi symbol. Okay, yeah. Pi 1 by sigma root 2 pi into e to the power of minus 1 by 2 into xi minus mu by sigma whole square. Okay, so once I'll tell what is the meaning of pi. For example here, e to the power of minus 1 by 2 x1 minus mu by sigma whole square. This is x1, and in the next step we can write x2 minus mu by sigma whole square. Like that we go on writing xn terms, no? That means all these terms will be in the form of what? Multiplication. To make it as a single term we use this pi. Okay, as we all know that x1 plus x2 plus and so on, if the xn terms are there, to write in a single format we can use summation xi, no? So in the same way we wrote these terms in the form of pi. Okay, yeah. This is first step. Now what we have to do is, in the second step we have to apply log. Okay, we have to apply what? Log. So L of mu comma sigma equals to log of pi I equals to 1 to n 1 by sigma root 2 pi into e to the power of minus 1 by 2 into xi minus mu by sigma whole square. Okay, so here pi I am going to write outside. So pi I equals to 1 to n log of 1 by sigma root 2 pi into e to the power of minus 1 by 2 into xi minus mu by sigma whole square. Okay, if you observe, it is in the form of log of AB equals to log A plus log B we can write, isn't it? Log of AB equals to log A plus log B, we have to use formula now. So log A term is this one and B term is this one. Okay, so pi I equals to 1 to n log of 1 by sigma root 2 pi plus log of e to the power of minus 1 by 2 xi minus mu by sigma whole square. Okay, so pi I equals to 1 to n. See, again we can write this one log of 1 by root 2 pi into 1 by sigma. We can split again. Plus log and e both gets cancelled. So that means what is the term remaining? Minus 1 by 2 into xi minus mu by sigma whole square. Okay, so again pi I equals to 1 to n log of a plus log b. That means here we are going to use what terms? We are going to use here log a plus log b, no? So that means plus terms we are taking. Here only we have to change this pi as summation. But here I am going to change. You can also change here. Why? Because log a b we are writing log a plus b, no? That means into terms we are going to change in the form of plus terms. So that at the time pi is going to change as summation. Okay, so you can write here itself, or else you can change here, nothing happens. So summation I equals to 1 to n again log 1 by root 2 pi plus log 1 by sigma plus into minus, nothing but minus 1 by 2 into xi minus mu by sigma whole square. Okay, so summation I equals to 1 to n. This term I am going to write. See here, if 1 by x is there, what we can write? 1 x to the power of minus 1 we can write, no? So like that only I am going to write this term. 1 by root 2 pi I am going to write minus root 2 pi. Okay, so that means log of minus root 2 pi plus log of what? Minus sigma minus 1 by 2 xi minus mu by sigma whole square. Okay, so again what I am going to do is here, see, summation I am going to split for every term. Okay, so summation I equals to 1 to n. So here minus, what we have to do? Minus we have to bring out. Okay, so minus log root 2 pi minus summation I equals to 1 to n log sigma minus 1 by 2 summation xi minus mu by sigma whole square. Okay, so now how we can write this term? So in place of summation we can substitute what? N. Yes or no? In place of summation. Summation in the sense what? All the n terms we are going to add. So in place of summation we can simply write that n. So that means minus n log root 2 pi minus, in place of summation again I am going to write n log sigma minus 1 by 2 into sigma whole square, 2 sigma square summation xi minus mu whole square. Okay, so again here this term what we are going to do is we are going to differentiate. Okay, partial differentiation. Okay, so the above term differentiate, partially differentiate with respect to mu. Okay, with respect to mu. Why? Because we are going to find out what? Mu value. Or else we can think this is equation 1 and differentiate with respect to equation 1 with respect to mu. You can write like that also, no problem. So, dou L mu comma sigma by dou mu equals to, here the mu term is not there, isn't it? So that's why we keep here 0, and here the mu term is not there, so that's why again we keep here 0, minus, here the mu term is there, so it is in the form of x square. What is the derivation for x square? 2x, isn't it? Yeah, so this is constant, so 1 by 2 sigma square 2 into summation xi minus mu, what? 2 minus 1. See here, for example, x square is there. Derivation of x square is nothing but 2x to the power of 2 minus 1. Isn't it? Nothing but 2x. 2 minus 1 is 1, no? So 2x. So like that only here, 2 summation xi minus mu, and again we have to do for mu, no? So that's why here we get minus 1. The coefficient of mu is minus 1. Okay? Yeah. That equals to, what is the value here? 2 gets cancelled. So minus and this minus plus. So that means 1 by sigma square summation xi minus mu. Okay? So this is differentiation with respect to what? With respect to mu. So now we have to equate this one to 0. So that means equals to 0. What we get here? This term from LHS to RHS, it becomes 0. That means summation what? Xi minus mu equals to 0 into 1 by sigma square, nothing but 0. So summation xi minus mu equals to 0. So summation xi minus mu equals to 0. So what I am doing is summation xi minus summation mu, that equals to 0. So this one from LHS to RHS I am taking. So summation xi equals to what? Summation mu. So here in place of mu, what I can write? In place of summation, what I can write? N I can write, no? So summation xi equals to n mu. So mu equals to, what is the formula? 1 by n summation xi. So this value from RHS to LHS if it comes. So it is proved now. So that's why. So summation xi minus summation mu equals to 0. So summation xi equals to summation mu. So summation place we can write n. So summation xi equals to n mu. So here mu equals to what? 1 by n summation xi. So we proved it now. So mean value. Okay. Now what we have to do is we have to differentiate the equation 1. Now we have to differentiate this equation 1 with respect to sigma. Why? Because we have to prove standard deviation also, no? So now differentiate with respect to sigma. Okay, equation 1. Partial differentiation ma. So that is nothing but, so here sigma term is not there. So this is 0. And here the sigma term is there. And here also we are having the sigma term. So this both I am going to differentiate. Okay. So here, see this term I am writing here so that you will understand. So n log root 2 pi minus n log sigma minus 1 by 2 sigma square summation xi minus mu whole square. So now we are going to differentiate this term. See here, dou L mu comma sigma by what? Dou sigma equals to, here if you observe here we are not having any sigma term. So that's why it is 0. Now minus n. So it is in the form of log x. So what is differentiation of log x? Nothing but 1 by x. Okay. So n minus n 1 by sigma minus, here we are having sigma term. So that means this is constant. Okay. So what we'll get here? 1 by sigma into, first I am going to write this term as, see here, 1 by 2 sigma to the power of minus 2 I am writing. So that what we can write, x to the power of 2 is nothing but 2 into x to the power of 2 minus 1, no? So that's why sigma to the power of minus 2, in the sense minus 2 into sigma to the power of minus 2 minus 1 will get, no? So that means what? Minus 2 sigma to the power of minus 3 will get. That means what? In place of this one we can write this one, no? Isn't it? So that means 1 by 2 into minus 2 sigma to the power of minus 3. In place of this one I am going to write this one, and these are constant, as it is I am going to write. So that is nothing but summation xi minus mu whole square. Okay. So that equals to minus n by sigma. So here and here minus minus plus it becomes 2 gets cancelled. So plus sigma to the power of minus 3 summation xi minus mu whole square. Okay. So that equals to what? Here minus n by sigma plus sigma to the power of minus 3. So if you see here, what we can do is, here in place of this we can write, see, sigma square equals to, what is the formula? 1 by n summation xi minus mu whole square. So now we want only this term. We want only this term. That means what? We can send this n from RHS to LHS now. So that means what? We can write n sigma square we can write now. So in place of this one, what we are going to write now? N sigma square. Okay. So we are going to write what? N sigma square. Okay. Or else you can keep like that also. Nothing happens in that. Okay. We will keep, see, minus n by sigma plus sigma to the power of minus 3 summation xi minus mu whole square equals to 0. We are equating this term as 0. Okay. So now what we have to do is, this term 1 by, again I am writing this as 1 by sigma cube summation xi minus mu whole square equals to this term from LHS to RHS. If it goes, the minus will vanish. So that means n by sigma. So n by sigma we are having. Okay. And the next is, so 1 by this term from LHS to RHS. It is in the form of multiplication. If it goes to here, it becomes division form. 1 by means multiplication, no? So that's why from LHS to RHS it goes, it becomes to multiplication format. So that means, so summation xi minus mu whole square equals to n by sigma into sigma cube. So sigma get cancelled. So summation xi minus mu whole square equals to n sigma square. So now we want what? Sigma square value. Sigma square equals to this term from RHS to LHS. If it comes, it will become division. So 1 by n summation xi minus mu whole square. Okay. So sigma equals to what? Square root of 1 by n summation xi minus mu whole square. So we got the value now. Okay. So hope you understand. Okay. So if you did not understand any step, please comment. Hope you all understand. Why? Because each and every step I have explained to you. Okay. Thank you. Have a nice day. Please, if you like, please like. You are not going to click on the like symbol. Please like, share and also subscribe. Thank you. Have a nice day.